All right, hey guys, 9-1. I'm gonna introduce this. We're gonna do a couple problems, and then I'm gonna give you some things to work on. But there's 3 sheets of paper that goes with section 9-1, the notes, and then there's like 2 assignments. Okay, the first assignment is like one that just has formulas on it, and it's really ugly. That's the one that we're gonna do first. Okay, so chapter 9. Here's how it's different from chapter 8. Ready? In chapter 8, I'm gonna write at the top of the paper. Chapter 8, we would do stuff like. Let's say the percentage of stats kids, like we would do like our H0 and our H1. H0, H1. We would say like the percentage of stats kids that pass the test is, or no. Let's just say the percentage on this test is equal to 80%. No, let's go 90%. We'll go 0.9. The percentage on this test is equal to 90%. Okay? And then the percentage on this test is not equal to 90%. And we would test that, right? Like the percentage on the test, whatever. Okay? That's just dealing with just this test. Okay? In chapter 9, our hypotheses look like this. H0, H1, we are comparing 2 sets of percentages. So we would say the percentage for this test is equal to the percentage on the last test, or the percentage on this test is not equal to the percentage on the last test. Does that make sense? So, like, are the percentages comparable? Are they about the same? Or did one chapter you score, like, as a class, average, did you score higher than the other class? So we're doing 2 proportions rather than doing just one like we did in the last chapter. We're not comparing them to a number, we're comparing them to each other. Does that make sense? That's why these formulas are a little bit uglier, just because you have like 2 sets of data to deal with instead of just one. But hypothesis testing is going to be exactly the same. You still have like your 2 tails or 1 tail, greater than, less than, that type of thing. It's just like calculating your test statistic is this guy. Okay? Yeah? Lots of stuff. All right, so let's go through some variables. We still have P and we still have P hat. So starting with those 2, P and P hat. Yeah? P is the population, P hat is my sample. Sometimes they will give you not a percentage for P hat, and you'll have to calculate it. So they'll say like 10 of the 17 passed the test. You would take 10 and divide by 17 to figure out that percentage, right? That's P hat 1, okay? And then you'll have a P hat 2, which is the second population, or second sample, and P2, which will be your second population. Does that make sense? Lots of stuff. So P and P hat, P1 hat, P2 hat, that's second set of data. Okay, you'll have a Q hat 1 and a Q hat 2 calculated exactly the same. Find P hat 1, right? So like they might say 10 people passed the test out of 17. Yeah, a little bit. Okay, we'll do one of these examples and it'll be not too bad. The corresponding notations P2, N2, X2, P hat 2, and Q hat 2 also apply, but that's for population 2. So all of the same variables, it's just labeled as P1 instead of just P, because now we have 2 of them, right? So we'll have a P1 and a P2, okay? Confusion? Lots of stuff? Okay, I'm going to make this formula simpler for our test statistic. We still call it Z because we're dealing with proportions, and proportions deal with the Z table. So the only chart we're using is the Z chart, just like we always do for proportions. Just the Z chart, that's it. You're still looking stuff up on the Z chart because proportion is Z, okay? Now, I'm going to make this formula just a little bit simpler. When we do a hypothesis test for a proportion, our first or our null hypothesis, we always say is equal to, right? But instead of it being like P equal to a number, it's not like that anymore. It's P1 is equal to P2. Okay, ready? Good? Confusion? Okay, now I'm going to show you in this formula one thing that always takes place. They're wanting us to say P1 minus P2 in the formula. Okay? Now, we are under the assumption that P1 equals P2. Okay? If P1 equals P2, what will P1 minus P2 be?
0.
0. So in the formula, Yeah, they have P1 minus P2, but if we're assuming equal to, which is always the case, we always assume equal to for our null hypothesis, this number will always be 0 in that spot. So that kind of knocks out the top half of the numerator of the formula. That makes it a little nicer, right? Yeah. They put that in there because P1 minus P2, they have to have in there, but if we're always assuming equal to for our null hypothesis, it will always be 0. Happy with that? Okay, so really we just have to calculate this chunk, okay? And now, you can cross it out if you want. Yeah, that's fine, okay? Because it'll always be gone, okay? Now there's one more thing that they've added in there, and it is called P bar. This is stupid. P bar, it'll get a little bit better. Okay, this is called the pooled sample, okay? And so, let me give you an example of P bar, okay? So let's say in test 6, in chapter 6 test, and in test 7, okay? We had 12 out of 17 pass. And in test 7, it was a little bit harder. We only had 10 out of 17. I'm lying, I'm making these numbers up, right? We didn't have that many people fail. So 12 out of 17 passed, 10 out of 17 passed. If we're trying to find P bar, we would do 12 plus 10 over 17 plus 17. Does that make sense? We would just combine the two tests together. How many passed out of the total, right? So in that case, it would be 22 out of 34, and that is a decimal is point something. 22 divided by 34. Is 0.65, yep. Does that make sense? That's what P bar is, okay? That's just an example of how P bar works. And then you use P bar in this formula. It's a lot. It is a lot. I'm not going to lie to you and say it's not a lot, because it is a lot, okay? Woo, we're going to take this baby steps, especially since there's people that are not here. It's going to be okay. All right, so we're going to just start by, and the only thing we're going to do is we're not even going to do the full hypothesis test for example 1. We're just going to find like this stuff that we need up here, okay? So we need a P. We're going to say P1 equals P2. That's what we always say for our hypothesis test. So P1 equals P2, and then P1 is... We got to read the problem. We're talking about rear license plates only. So did you know that in some states you only have to have a rear license plates? In some states you can have both, right? Or you have to have both. A lot of people just have both just because, you know, some states require it, but some states you only need to have a rear license plate. So the percentage of people in Connecticut that only have rear license plates is about 12%. The percentage of people in New York who only have rear license plates is about 2%. Okay, so we're trying to see if those percentages are the same. Do you think that those percentages are the same?
Yes.
You think 12% is pretty close enough to 2% to say that those are equal? I think he's lying. I don't think that those are the same, but maybe they're going to say that they round to be like the same. We'll see. Okay, so we're saying that they're equal. Now, does it say that one of them is greater than the other? To test the claim that Connecticut and New York have the same proportion. So we're just going to do equal to, not equal to. So we're going to say Connecticut versus proportion, or Connecticut versus New York are equal to, not equal to. Now, which one is Connecticut? The ones or the twos? The ones. They did P hat up here. So the ones are the Connecticut's, the twos are the New York's, okay? We're just going to do this stuff. So we don't have actual values for P1, P2. We only have P1 hat and P2 hat. These are things that we need, okay? Good? Yeah? All right, P1 hat, P2 hat, they've calculated here for us. They said P1 hat is 0.117, so 11.7%-ish. P2 hat is 0.016, okay? Now, in my formula up above here, I need to know what N1 and N2 are. And I need to know what X1 and X2 are. Yes, so from the fractions that they did right here, what's N1? 2049, right? And x1 is the 293, or 239. I'm dyslexic. There you go. Okay, do you see where we're getting these numbers from? Okay, x2, what's x2? Or excuse me, n2. 550, x2, 9. Questions about this? This is a lot of stuff, guys. Lots of stuff. I'm not going to try to sugarcoat it and say it's not ugly, because it is. But I will say that it does get better. You do like start to understand and like get used to plugging stuff in and all this good stuff, okay? All right, then the last thing that we have to find is p bar and q bar. And do we need p hat? No, we don't need p hat 1 or p, yeah, we don't need q hat yet. I don't think. Okay, so p bar is the one where you add the tops and add the bottoms. So we're adding the tops is 239 plus 9. 239 plus 9 is 248 over whatever that is, 2049 over 550. And that is what? 25.99. Okay, find that as a decimal. 0.095. Perfect. That's what P bar is. Okay, what will Q bar be then? I'll slow down. Okay, P bar is like 9.5%. 1 minus that, yes. 0.905. There we go. So we have a lot of our calculations already done. We're just going through. There's a lot of things that you need. Okay, lots of calculations. Anybody want to be a statistician and work for a company that has to crunch these numbers all day long? Was it last year? Tori Olson, she was all over this. She's like, yes, let me do this all day long. This is my job. I want to do this. I would like it, but then again, it's not for everybody. Because at the end, when you come up with a conclusion, you're like, yes, look at all the work I did, and I know it's right, and it's very satisfying. I don't know. In the middle, you're like, I hate my life, I want a new job. But at the end, you're like, huh, but look at what I accomplished. It's really cool. I don't know. That's not for everybody. That's just what I think. And Tori was in the same boat. Okay, next thing we have to do. So we've already found P bar. We got to find Z, and this is the last thing that we're going to do, and then we're going to jump to the assignment and have you do that stuff. Okay, so we already know that we can cross this like right side stuff off, right? Because P1 minus P2 should be 0 if P1 equals P2, okay? So I gotta get this all on one screen here. Z equals, I'm gonna put it over here. All right, on the top, we've got P hat 1 minus P hat 2. So 0.117 minus 0.016. Okay, on the bottom, open up a massive square root. And you got two things that you're going to put together. P bar, Q bar. 0.095 is P bar, right? Yeah. And then 0.905. And then 0.0955. And 0.905. And the bottom numbers are my N1 and N2, which is 2049 and 550. That's a lot of things. That's a lot of things. Okay? What? Okay. At the end of chapter 9, I'm hoping that we get to that point. We do comparing statistics from ACT before John Baylor and ACT after John Baylor. That would be like an example of when this is relevant, right? Like data before John Baylor, data after John Baylor. The people who are like forcing you to pay tons of money, like for John Baylor, like if they can't prove that it's effective, then like, and if they're able to prove that John Baylor is effective, if they're able to say and back it up with statistics saying like, we tested samples of blah, 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 and in 99% of our studies, John Baylor was effective at increasing your test score at least 3 points. You know, if they're able to tack that on to the end of their advertisement, they're going to sell a lot more. But they have to back it up with data. Does that make sense? Like, it's ugly, and we don't care. But those companies make a lot more money if they're able to say this, right? So they have people working for them to crunch these numbers to figure out, whatever. Okay? What? Maybe. We'll see. Oh, over this chapter? We'll see. I have a test ready to go. Okay. Do you guys have calculators?
Yeah.
Why don't you practice typing it in just to see if we get all the same? You did get an answer? Okay. Let's see if we get the same answer as Kelsey got. Because Kelsey got something. What'd you get, Kelsey? What? 7.173. Okay. We're still dealing in z-score land, right? And z-scores typically go from -3 to 3. But remember the two percentages that we're comparing. We're comparing 12% here to 2% here. So a z-score of 7 probably means we're going to say that those are not the same. What'd you get? You got 2.5 something? 2.51. You got to open up like lots of. You got 7.17?
I got 7.17.
All right, let's see. 0.117 minus 0.016 over square root open 0.095 times 0.905 over 2049 plus holy bejeez. Now make sure that when you're doing this whole bottom part is underneath of the square root still. Yeah. I got 7.17. 3. This is what I got. I didn't get 2.51. What? Oh,
Yeah.
0.095. This is 0.905.
Oh.
Yeah. So you switch the numbers now. Okay. I got 7.17.
Let's go.
Did you get it?
Yeah.
Yay! So you gotta celebrate the little successes because this is, this is just absolute madness sometimes.
This first lesson might be a week.
This first lesson, I know, but see, that's why I'm like, we have a month. We might use a month. You betcha to get through this chapter, and it's only like what 3 sections long, maybe 4.
We have 16 days.
Yeah, I don't know. We're gonna be pushing it. Okay, 7.17. Did you get that? Yes.
Yeah.
Maybe.
Yeah.
Yes. I don't know. If you didn't get it, I can come help you figure out what you did wrong. But let's go to this stuff. Okay? 1, 2, 3, all the way through. Man, oh man, look at this madness.
So what we're doing is plugging stuff.
Okay, what I want you to do is just, we don't know how to do number 4 yet, so 1, 2, 3. Okay, pay attention to what they're asking you to find. Here, they're just finding P bar. That's easy. Here, they're having you find Q bar, if this is P bar, right? Like they're trying to make it easy on you. Number 3, plugging all of the things in, keeping in mind that this guy should be 0. Okay, so do 1, 2, 3. We don't know how to do 4 and 5 and 6 yet, but we can do.
Let's just do one, 2, 3, top 3. Please. This is commentary. This is a lot of work.
Yeah, let's just do top 3 because we don't know how to do the rest of them. So just do 1, 2, 3.
Yeah.
There you go. Okay, that's all. Do those 3. Beautiful. All right. Ooh, I don't know.
Huh?
All right, bye people in the video.